What's up? I'm Vin, and today I want to show how to simplify trig expressions. So we're going to start off here. Question 1, we're going to simplify. We have cosecant theta times sine theta. So this is about as straightforward as it gets. So the identity for cosecant, this is the reciprocal of sine theta. So we could rewrite this as 1 over sine theta times sine theta. And then notice here, these factors just cancel out. So the first question just simplifies to 1. Now, for the second question here, let's say I look at sine theta times cotangent theta. Now, for this one here, sine theta we're going to leave alone. But for the next piece, we have to know the identity for cotangent. That cotangent theta is equal to cosine theta over sine theta. We could rewrite it as 1 over tangent theta, but then we would make another substitution and say that tangent theta is equal to sine over cosine. So 1 over sine over cosine is going to give us this anyway. And then notice sine theta over sine theta cancels, leaving us with just cosine theta. And for the third example, we'll look at another one. We have tangent theta times cosine theta. And for this, the identity for tangent is equal to sine over cosine. And then we have times cosine here. So in this case, cosine over cosine cancels, leaving us with just sine theta. So for the next set of questions, we'll up the difficulty a bit. So let's say for question 4, we have secant theta times cotangent theta. And for something like this, we have to transform both expressions. Secant theta is equal to 1 over cosine theta, and cotangent theta is equal to cosine theta over sine theta. And then from here, cosine over cosine cancels, leaving us with just 1 over sine theta. But this isn't as simple as we could write this. We could simplify this a little bit more. The identity for 1 over sine theta is cosecant theta. So this will simplify question 4. Now for question 5, let's say here, next we look at secant theta divided by cosecant theta. So for something like this, there's a few ways you could deal with this, but I'm going to rewrite the numerator as, and we'll just make a dividing line here. So we'll rewrite the numerator as 1 over cosine theta. And the denominator we'll write as 1 over sine theta. So now if we use the technique to divide fractions, some people know this as keep, change, flip, but we could write the first fraction times the reciprocal of the second fraction. And then notice here, we're going to be left with sine over cosine, and the identity for sine over cosine is just tangent theta. So now let's look at something a little bit more complicated. So for question 6, let's say we look at the identity or the expression cosecant squared theta minus cotangent theta over tangent theta. And we want to simplify this expression. So what we could do is we'll transform the first piece. Cosecant squared is the same thing as 1 over sine squared theta. And then for the next piece, we have minus, and we'll make a lot of space. The expression on top, cotangent, we could write as cosine theta over sine theta. And the expression on bottom, tangent theta, we could express as sine theta over cosine theta. And then in the next line here, we'll just kind of divide this here so we don't mix this stuff up. We're going to say that this is equal to, we have 1 over sine squared theta minus, and this we could rewrite as cosine over sine times the flip of this, cosine over sine. So if we do cosine over sine times cosine over sine, that's going to give us cosine squared theta over sine squared theta. And now we have two fractions that have the same denominator, so we can combine these into a single fraction as 1 minus cosine squared theta over sine squared theta. And at this step, we have to recognize the identity for 1 minus cosine squared is sine squared. So this is going to give us sine squared theta over sine squared theta, which this is just going to cancel and equal 1. So here's our answer to 6. But just know, where did I get that identity from? There's a famous identity that you have to know, that sine squared theta plus cosine squared theta is equal to 1. So anytime I see 1 minus cosine squared, I just say sine squared. And when I see 1 minus sine squared theta, that's just going to give us cosine squared. And for the last question here, question 7, we're going to look at secant theta times, and in parentheses, we're going to have 1 plus cotangent theta. We close the parentheses, and we're going to have minus cosecant theta times 1 plus tangent theta. So this expression is very messy. So the best thing I would do here is just convert this stuff first. So I'm going to rewrite secant as 1 over cosine theta. And we're going to have 1 plus, we're going to write this as cosine theta over sine theta. And now we're going to have minus cosecant theta is 1 over sine theta. And then we're going to have 1 plus tangent theta is sine theta over cosine theta. So now we could distribute this. So we send this term through, and we're going to have 1 over cosine theta plus 1 over cosine theta times cosine theta over sine theta. So just looking at this right away, I see cosine over cosine cancels. And then when we distribute the minus 1 over sine theta, so we send this through, we're going to have minus 1 over sine theta times 1 is 1 over sine theta. And then we have minus 1 over sine theta times this expression, sine theta over cosine theta. So from here, if we look here, sine theta over sine theta cancels, and we're left with, in this line, so we'll just put a bunch of equal signs here, we're left with 1 over cosine theta plus 1 over sine theta, and then we're going to have minus 1 over sine theta minus, and we're left with 1 over cosine theta. So if we pay close attention here, 1 over cosine is going to cancel out with minus 1 over cosine. And 1 over sine is going to cancel out with minus 1 over sine. So this whole thing is just going to equal 0. Okay, well, this is going to conclude this video on simplifying trig expressions. If this video was helpful, please like and subscribe. It really helps me grow the channel. And if you got any requests, just leave the topics you want me to cover in the comment section below. And thanks for watching.